thing to be told as I walked into the building.
Oh, yeah, sure.
Like, no, don't say that.
Well, I'm like, they're sending my router, my modem, they're definitely gonna be coming in. I'm like, I don't get it, I'm like,
Yeah.
so.
Well, that smells like, yeah, and probably standard, like boilerplate things they tell everybody.
Yeah.
They probably got a script that they're reading that's like, yes, we will try not to come in and kill you. Blah, blah, blah.
I've never heard of a company going inside the house when they've had to do something inside the house, like, I don't know, it's just, usually either you schedule it for some other time when it's not a big issue, or.
Yeah.
I'm doing the math on, but, I don't know. We'll see, I guess. My fingers crossed. I was in the library yesterday, and they're like, oh, the library closed at 11, I'm like, oh. Crap. So, yeah, I moved. So I thought it was still open till 1, but I guess not.
Are you talking 11 p.m. and 1 a.m. or?
Yeah.
Oh, yeah. No, I'm sure that they've had to cut down on their hours.
Yeah.
The whole university system is having to make a lot of adjustments for monetary reasons, among other things, just because there's so many fewer students attending. And so, come in. Hey, Yeshwant, can you hear me?
Yeah. Am I audible?
Yep, you're audible. Is the echo situation better or worse or the same as it's been at previous class meetings?
I think on Monday and today it's a lot better. I think last week it was definitely there.
Okay, so Friday was really bad, but you think it's a little better today?
Yeah, like
Okay.
I don't really notice it now. I don't know, maybe if you like talk like closer to the center of the room, it'll get worse. That's what I remember happening on Friday.
Ah, okay. Well, I will actually probably stay in this corner of the room today. I don't think I'll need to use the tablet, so I think I'll probably just stay here and work on the laptop over here. So, but, if any of you online, if that echo starts to come back, let me know, because I'm still trying to figure out why that was happening and how we make it not happen, because that Friday's recording was really almost inaudible. And that's not good. We want to definitely do better. So thank you for your help and your patience. Okay, we should commence. Yeah, I think we're good to go. So hi, everybody. We will be talking today about sort of the end of chapter 2, and we will start the beginning of chapter 3 as time allows. And this will be focusing primarily on strings, but we'll do a little bit about images so we can see some of the things that Jess allows us to do with images, since that's sort of why everybody's here. If there's time, we will introduce the idea of functions, which are particularly important and will be quite crucial for the entirety of the semester. Okay, so that'll be a really important concept. Don't know if we'll get to it today. If we don't, we'll certainly be talking about it on Friday. Okay. Are there questions about anything so far that I can help with before we begin? And I am fogging up something terrible. You're just all blurry blurs. You're just different blurs without my glasses than with my glasses. Anything? Questions? Okay. Then let us commence. So there is a quiz for chapter 2 on Canvas now. There'd been an old homework exercise for chapter 2 that I realized we could turn into a quiz and have grade itself, so you get feedback immediately on it. And so last night I turned that into a quiz. It's basically a set of exercises from the end of chapter 2, where you type in some stuff in Jess and then enter in the quiz what the result was from doing the stuff in exercise, whatever. And actually I'll do an example to show what that might look like. Let's see, stop sharing that and start sharing Jess. Now I'm gonna make the screen a little wider. That's for those of you who are at home. This pulls the bottom of the image up off the bottom of the screen a little bit, which makes it a little easier for people in the back of the room to see here in the room. So if we take as an example, well, let's just take the very first one, 2.16. So 2.16 says, what is the output from the following? And then it has you enter some things in Jess. So the first line is, and I'm going to also move this up some so we have more room here. A equals 3. And is that big enough? Is the color okay? Can people read this okay? Cool. A gets 3. B gets 4, X gets A times B, and print X. So these are the things in the exercise. So if you look in the book at exercise 2.16, this is what it tells you to do. Okay? Does that make sense? And so your job is literally just to type that in. You don't have to do anything fancy, just duplicate what the book says. Okay? Questions? And then when you do it and you hit return or enter, you get a value. So they all end with a print statement, and prints a value out. So in this case, the value that it printed was 12. So in the quiz, there's a box where you enter the value that was printed. You would type in 12. And that would be your answer to that question on the quiz. It's that straightforward. Like, don't try to imagine it's something complicated or mysterious. Literally, you type the stuff in, you get a value, you enter it in the box, and you're finished. Okay? Does that make sense? Questions about that? And there's then a bunch of those, I don't know, there's like 10, 12 of them. And the idea is to make sure you've actually poked at Jess and tried some things. Also, part of the idea is to encourage you to ask questions. So if you do an exercise, and even if you get it right, if you're not sure why it did what it did, like that would be a great question. You should totally ask that, okay? If you didn't get it right, like, and you're not sure why, that would be an even more important question, because you don't want to not understand why you're getting things wrong. But even if you do get it right, absolutely ask a question if you're uncertain as to why something did what it did. Okay? Questions? Now, this example illustrates some things that I wanted to talk about anyway. So how convenient is that? The first is this idea of a name on the left, an equal sign, and a value or an expression on the right. This is an assignment. We are assigning a value to a name. The value is the value of whatever expression appears on the right-hand side of the equal sign. And the name we're giving to that value is the name that is on the left-hand side, okay? This is not equals as in math equals. This is a different sort of thing. This is a verb that assigns a value to a name. It is not checking are two things equal. There is a way to check if two things are equal, but that's a different operator. We'll talk about that later. Now, I would argue it was a poor choice on the part of people who were making these choices when I was a child and long before you were born to use the equal sign for this, because the equal sign means test if two things are equal in math. That's a perfectly good meaning. It didn't need to have a new, different meaning in computer science. We really probably should have used a different symbol. And there are some programming languages that did use a different symbol, but for historical reasons that go back to that sort of language history chart that we looked at last week, it just worked out that almost every programming language now uses equal to mean assignment, not to mean test if two things are the same, okay? So we are assigning the value on the right to the name on the left. And it's critical that the names on the left and the values on the right. If I tried to do something like 4 equals C, it's like, whoa, instead of an error, like it even gives me this 3 dots and doesn't say anything. And you're like, what is that about? Okay. It's actually asking for some more input. It thinks that somehow we can finish this statement in a meaningful way. And I'm actually going to do Control C to say, oops, Control C is not the right thing. Control D. How do I, oh, there we go. I just hit return. To say, no, I'm done. And then we get this invalid syntax. Your code contains at least one syntax error, meaning it is not legal Jython. A totally unhelpful error message. This is basically the computer going, bleh, but providing no feedback. It's sort of a toddler screaming at you. You're like, I don't know what's wrong. Are you sleepy? Are you hungry? What is the deal? And the kid's just like, ah! Jython's a lot like that, okay? So we get messages like this that provide no useful information. And for this, I apologize. But we can't assign in that direction. We can assign in this direction, and we can look at the value of C, and it is indeed 4. Okay? And as the example shows, we can do complicated math. Okay? We don't have to just use simple numbers. We can also reassign. Notice that C has now had 2 values. It was 4 a little bit ago, and now it's 44. So if we do an assignment to the same name, the new value overwrites the old value. Whatever value we used to have for that name gets replaced by the new value for that name. And that's important, okay? And we can have we can refer to other variables in an expression, and it will use whatever the current value of those variables happen to be. So in this case, B was, oh, it scrolled off, so let's print A and B again. B was 4, so 4 plus 7 is 11. A was 3, 3 times 11 is 33. So C got the value 33. Does that make sense? Questions about that? Okay. Now here's the one really weird one. We can do something like this. Now, this is one indication that we're not using equals, because there is no number that's equal to one more than itself. So that's just kind of an incoherent thing to say. So again, though, the same rules apply. We evaluate the expression on the right by looking up the values of any variables that are mentioned, evaluate that expression, and then assign that value to whatever name is on the left. In this case, the value of C that we find, if we look it up, is 33. We add 1 to 33 and we get 34. 34 is then assigned back to C. So C used to be 33, but now it's 34. And if we print C, we should get, indeed, 34. Okay. Questions? So this is really crucial mechanics, okay? Like this idea of giving names to values is really central to a lot of computing. Naming of things, as the book talks about, is really an important part of computer science. And if you have questions about this naming and assigning values, this is going to keep coming up over and over and over again. So definitely ask questions. Okay. Any questions? Awesome. Okay, so now everything we've done so far has been with numbers, but we can also do things with strings of characters. And so in some ways, this is the first type of media that we'll talk about. We'll spend more time, because it's more complicated, on things like pictures and sound, but text is a perfectly important and reasonable kind of media, okay? In fact, you process more text media probably than you do anything else. Although with Netflix these days, maybe you process more video media, hard to say. But certainly your parents processed a lot more text than they did probably anything else. And so being able to handle text as media, as content, is really important. And so we can do things like name equals Nick. Now here, the value on the right is the string Nick, the sequence of characters NIC, okay, my name. And it's important that we put quotes around those. If we don't put quotes around it, it's going to take NIC to be a variable name and try to find its value. So if we say X equals Nick, we're going to get a message, an error, saying the name Nick is not defined. The name is not found globally. A local or global name cannot be found. You need to find the function or variable before you use it in any way, which is a slightly more helpful error message. It's basically saying that Nick as a variable name is not defined. It tried to look Nick up as a variable name and find its value and then assign that value to X, but there was no variable called Nick. And so it couldn't do that. It failed when it tried to look up Nick. But if we put quotes around it like we did on the name equals line right here, okay, then we're saying, don't treat this as a variable, treat this as a sequence of characters, a literal sequence of characters. Don't treat it as the thing, just treat it as the sequence of characters, okay? Does that make sense? Okay. And so if we print name, It's Nick, right? And we can say school equals unit, so illustrate that. University of Minnesota Morris, print school, okay? And so we can have longish strings. Strings can have punctuation marks. They can have spaces. Remember from Monday, spaces are real characters with real values, right? A space had was represented by the number 32, okay? And so we can have long, complicated things. I did something different between naming Nick and naming University of Minnesota Morris. What is different between those two things? Anybody, here or at home? Yeah, I did. So Nick, and this is something where if the text is small enough that this distinction is hard for you to see, let me know and I will make the text bigger. But you need to be able to see that or this is not going to work. Like you're not going to be able to take notes or replicate things. So definitely let me know if the quote marks are too small to like really be able to tell the difference, okay? And that's true at home as well as here in the room. But Nick up here has double quotes around the string. So the shift double quote up on the sort of by the enter key on the right-hand side of the keyboard. School here, I used a single quote. I had just one, I used the single quote character, which is the unshifted version of the same key. And I can use either one in Python. Some programming languages allow you to use one, some allow you to use the other, some allow you to use both, but that's actually fairly rare. Python's actually okay with either one. So we can use single quotes or double quotes. It's important that we end the string with the same thing that we started the string. If you start with a single quote, you can't end with a double quote. And if you start with a double quote, you can't end with a single quote. Okay, that's really important. One of the nice things about having both kinds of strings is I could do things like say, reading equals single quote, they, oops, can't spell, they said hello to us. Because I started with the single quote, when it got to the double quote right here, okay, it didn't see that double quote as an end because it knew I started with the single quote. So when it got to the double quote, it didn't go, oh, Nick's trying to end the string. It went, oh, that's just a character. It's a double quote. I'll treat it like any other character and just include it in the string. And then when it got to the second double quote here, same thing. Saw a double quote and said, well, I'm not looking for a double quote as an end because it was started with a single quote. I'm just going to treat this double quote as any other character. And then when it finally got to the single quote at the end, then it said, oh, that's a single quote. I started with a single quote. This must be the ending single quote for this string. So I will treat this as the last, the marker at the end of the string, and I'll say we're done. Okay? Does that make sense? Questions? Can we see this okay? Should this be bigger? Good. I can't. It's so hard to read the room with everybody in the mask. And it's 9:15 in the morning and everybody wants to be back in bed. I understand. Okay. So, quote marks. You good with that? So we can make strings. We can actually also join strings together. So if we say first name is Nick and last name is McPhee, I could say first name plus last name plus, when we give it numbers, does number plus. Like it adds things like we're used to, you know, since we were kids. It turns out if we give plus 2 strings instead of 2 numbers, it actually concatenates them. It joins them together. So it took the string Nick, which was first name, and the string McPhee, which was last name, and it ran them together. And that's what we got as a result of first name plus last name. Okay? Notice that there is no space between my first name and my last name here. It doesn't magically know to insert a space. It literally just takes the 2 strings and jams them together. If you want a space, you're going to have to add that. It's not going to do that for you. Okay? And we can do that. We can say print first name plus space plus last name. And there actually is a, oh, wow, that didn't work. There actually is a space between those 2 quote marks. It's just so small, it's pretty hard to see. And that did put a space between Nick and McPhee. And actually, I am going to, is that in help? Where is, options? Let's do, is that a little better for readability? Did that improve things or make things worse? I got 1 thumbs up. I got 2 thumbs up. 3 thumbs up. Okay. Is this okay for people that are online? This color change, I got some thumbs up there. Okay. And I think one thing this does is it makes the fact that there's a space here a little easier to see. So we're going to try that. There are several, as you may have seen there are several color themes I can choose between. So if this one doesn't work for you, let me know. We can work on trying to find a better one. Okay. Questions about where we are at the moment? No one going? Okay. So we can do stuff with strings. Stuff with strings are cool. A question that might come up, and in some ways it's hinted at by the fact that plus can do things for strings as well as for numbers. There's a legitimate question about, can we move between numbers and strings? If we have a string that has a number that could be interpreted as a number, can we actually turn it into a number? And if we have a number, can we get the string version of that? Okay. So, and a string and a number that looks like a string are not necessarily the same thing. And this is something that can be hard to see. So if I say print 4 and print the string 4, they look the same when they get printed out. They look identical, but they're actually different things. The first one was a number and the second one was a string. Okay. And one way to tell that is if I said print 4 times 3, I get 12, right? If I print the string 4 times 3, I get 444, which isn't super obvious, but it turns out that if you multiply a string by a number, it gives you that many copies of that number, of that string run together. Okay. Whereas if you multiply a number times a number, you just get regular multiplication. Okay. So the string 4 is not the same as the number 4. The string is a string, that represents the number 4 in our minds, but is not the same thing as the actual number 4. Okay. Does that make sense? So we can in fact move back and forth between strings and numbers. So I can say str, let's see, let's do this. The string representation of 123 is str123, and that str converts something to a number. You can hand it a lot of different things, including numbers, and it will convert the thing that you handed it into a string. So str of 123 is a string with the characters 1, 2, 3 in it. It's not a number. Okay. So in particular, if I say print str123 times 7, I get that. So str123 turned it into a string, and then times 7 gave me 7 copies of that string run together. Okay. Whereas if I did regular multiplication, I'd get a totally different answer. Okay. Does that make sense? Questions? You doing okay at home? Okay. So str will take us from other things to strings. We can also go from strings to other things when it makes sense. So there is a function int that takes a string, and if that string can be interpreted as an integer, it will attempt to do so. Okay, and that really is a number. If we multiply it by something, we don't get the repeating string business, we get regular old multiplication. Okay, so that takes us from strings to integers. Now, it will fail if we try to hand it something that's not interpretable as an integer. So we got the error was frogs, inappropriate argument value of correct type. An error occurred attempting to pass an argument to a function. Not the most useful error message. What it's saying here is the argument is frogs. That's the thing we're handing the function. And that was an inappropriate argument value in the sense that it needed a string that could be interpreted as a number, and frogs was not something it knew how to interpret as a number. Which makes sense, because I don't know how to interpret that as a number either, right? That doesn't make a lot of sense to me. So it's not able to do that. It's also not able to print handle floating point numbers because it doesn't know how to interpret those as integers. So 3.4, it's like, well, I don't know how to do that as an integer. I'm gonna have a problem there. Okay. And it can't do things like strings that we would read as numbers, but which are not numeric. So we see TWO and we think, oh, that's the number 2. But the computer's like, that's the letter T. T's not part of numbers in my world. It's not a digit. I'm going to stop now and die. Okay. So we don't get very far attempting to translate a string like that. Okay. Now there is a float that handles floating point numbers, numbers with decimal points. So it does convert floating point numbers to strings containing floating point numbers to floating point numbers that we can do math on. Okay. So we've learned 3 new functions here. str converts things to strings. int converts strings that represent integers to integers. And float, which converts strings that represent floating point numbers to floating point numbers. So string goes from thing to string. Int and float go from strings to numbers of different types. Okay? Questions about that? You learned 3 new functions. You can write home and say, I learned 3 functions today, none of which you care at all about. But, you know, I did. Yay. Okay, questions about anything we've done so far? Questions online? No? Questions in the room? Good? Okay, awesome. Now, let's talk about function sum. We haven't actually talked about defining a function yet. And let's also talk about getting pictures so that we've seen some of that. Okay, so we'll start with pictures a little bit, and then we'll talk about function sum. Everything we've done so far is actually standard Python. Any Python system that you pull up will do all of the things we've done so far. What we're about to do is specific to Jest, okay? All the other stuff we've done, any Python system would do for you. But what we're about to do is specific to Jest, okay? And one of the things that we want to be able to do in media computation is open files that contain images or sounds and do things with them, okay? And that's specific to Jest in that it's a specific media computation thing that we want to be able to do. Regular Python can do this, but it's not as user-friendly. And they've made some specific decisions in how they've built this in Jest to try to make it easier for us to do what we're trying to do. And one of the things that we often want to do is find a file. We want to be able to open up the file chooser and go find a file. And so I might say, well, here, let's just do pick a file first. So there's a built-in Jest function called pick a file with the camel case, a file. And if I choose that, then I can, come on, go and choose a file. And so we talked about this a little on Monday. What this returns is a string, actually, a string representation of the path, the full path that gets you to that file that I just chose. So in this case, because this is a Windows box, it starts with the C:, which is saying that it's on the C drive. If you have a Mac, you won't have that. And then the sequence of folders or directories, users, McPhee, downloads, snow.jpg. If you're on a Mac, the slashes will go the other direction. And in fact, I think on Jest 6, this turns out we have Jest 5 on this computer. I'm working with them to get that upgraded. I think on Jest 6, all these slashes go the other way, or they're single slashes even on Windows. Here they're double slashes. I'm not quite sure why they're, well, I think I know why they're doing that, but I don't want to get into it. So I think you might get slightly different behavior if you have a Windows box than what I'm seeing here, because I think Jest version 6 handles this a little differently than just version 5 does. But regardless, you should get a string that is a path to the file you choose. Okay? And so lo and behold, there's a path, yay team. Now, we usually don't care a lot about the path per se. What we really want to do with a file is open it as a picture and look at it, right? Or open it as a sound and listen to it. That's really what we care about. So there is a function called make picture. And actually, to record this, I'm going to actually say file gets pick a file and do that choice again. And now I have a name for my string. So I don't have to like keep calling pick a file over and over and over again. So there's a function called make picture. It takes a path and creates a picture. And if I look at it, if I say, what's the value of picture? And notice that saying print picture and just typing picture did the same thing here. In Jest, if you just have an expression, it will evaluate it and print the value of the expression. So all those places where I was saying print all the time, I could have just given the expression. So I can say 3 times 4, or I can say print 3 times 4, and they end up telling me the same thing. So picture, it says it's a picture. It gives me the name of the file that the picture was constructed from, and it tells me how big it is. That in this case, it is 267 pixels tall and 400 pixels wide. So it's a fairly small picture. Your camera takes much bigger pictures than that. Okay, your phone, which is the same thing as saying your camera for most of us, I suspect these days, takes much bigger pictures than that. So that's great, but you know, it's if I say picture, oops, it helps if I spell it correctly. If I say picture, like you don't have any idea what this picture looks like, right? It's hard to appreciate the aesthetic wonders of this photograph if all you have is its name and how big it is, okay? That's not a very interesting way of looking at a picture, is it? So there is actually a show function that takes a picture and displays it. Oh, and look, it's in a different window, so that's not being shared. Let me stop sharing Jess for a second and share the picture window. That is really going to be frustrating over the course of this semester. So I think actually what I should do is probably, I'm going to actually share the whole screen, and we're going to resize some things so that that'll actually be less awful. Okay. Otherwise, we're going to have to be flipping back and forth a lot, and that's going to really stink. There. And so that's the picture that show opened up for us. Okay. And I bet I also need to increase the font size because that made it really small, and that's not good. Let's try 16. That's still pretty small. Options. 24. Is that fairly readable? Okay, cool. Okay, so showing picture, display this picture of a house in the snow in Massachusetts. Okay. So that's the picture that we displayed, and we got pick a file, allowed us to choose the picture on our computer, make picture, turn that into a picture object, a thing that Jess understands as a picture, and then show displayed the picture on the screen so that we could actually look at it. Okay, and all 3 of those things are Jess specific things. All of those are things that Jess knows how to do, but that regular Python wouldn't know. Okay. Does that make sense? Questions about that? Now, that was a lot of steps, right? We had to call pick a file, we had to call make picture, and we had to call show. We could combine those into a single step. By nesting them. This is saying, show me a picture. What picture? The picture that is constructed by calling make picture. What are we calling make picture on? We're calling make picture on whatever pick a file returns. So here we've got pick a file is happening first. It is passing its result to make picture, which is passing its result to show. So we have like a assembly line in a factory, and each of these functions is doing something and passing its result on to the next part of the process. And it starts from the inside out, which is sometimes confusing to people. So the first thing that happens is the innermost function, pick a file, it gets called, it generates a path, which it then passes to make picture. Make picture then constructs a picture object, passes that to show, and show will display the picture. Okay? Does that make sense? Questions about that? And so if I hit return here, this should bring up the chooser. And when I choose a picture, it should then go ahead and do all the things. If I say snow, bloop. So it did successfully find that file with pick a file, turn it into a picture with make picture, and then display it with show. So I could run all of that together in one thing, or I could do it as 3 separate steps like we did before. So I could have file equals pick a file, say snow, followed by picture equals make picture file, followed by show. And I end up in the same place. Both of those get me to the same place. And there's no particular, like, oh, you should do it one way or the other here. The people often find this approach easier to read because it's clear sort of what happens first and then second and then third. It breaks it up in a way that, in my experience, students often find easier to understand. The one downside of that, and it's a small downside, is that you have to come up with names for all the pieces. Notice we had to come up with a name for the file and a name for the picture. Then I just used file and picture as names, and that worked fine. But I had to make those choices. And I could have come up with good names or bad names, right? I could have said frogs equals pick a file. And goose equals make picture frogs and show goose. And that accomplishes the same thing. I end up with exactly the same result, but those names are really not helpful. Like, this has nothing to do with frogs or geese, right? Those names are completely useless. The computer doesn't care because the computer doesn't actually understand the names, doesn't understand anything. So they're just names. And computers like whatever, right? You call it heffalumps and computer's fine. But as a human reader, like using the names frogs and goose are really not helpful here. They're arguably anti-helpful because they make you think somehow this has something to do with animals when it has nothing to do with animals, okay? There are no animals in the picture that I can see. There probably are animals in the picture hiding in the woods or something, but I see no animals in the picture. So having to come up with names puts a burden on us to do that well. So that's the downside of doing it in steps like that, is we've got to name things as we go. Whereas if we just chain them together, we don't have the naming problem. But it becomes harder to understand because of the nesting. So, it's a thing, right? You got to make some decisions. However, there's a cool thing we can do. So actually, questions about the nesting and the naming? Anything about that? Online? Out in the room? Okay. So one of the things that we can do is we can define our own functions. And this can be a really useful way of encapsulating behavior that we want to reuse. So that's one of the key values of functions, is there are things that we do over and over again, like pick a file, make picture, and show. Okay. That sequence of events comes up a bunch. And it would be nice if I didn't have to type all of those steps every time. It also means we can make a decision about those names, if we're going to do it with the names, once, and hide that inside the function definition so we don't have to worry about it anywhere else. It can be a local decision we make one time and that no one else has to care about. There's a lot of really nice things that come with functions, and functions are going to be very, very crucial throughout the rest of the course. So let's start a function. And you can type functions down in the commands area, but usually you'll type functions up in the definitions area. It'll make more sense because you want to reuse functions. So having them up there where you can save them in a file and bring them back, good thing. So I'm going to define a function that I'm going to call show picked file. Okay. I just made up the name show picked file. I could have used any name. The function could have been called heffalump or lawn chair or whatever. Okay. You want to choose a name that is helpful and informative to your human readers. And so I'm hoping that show picked file will say something useful to my readers about what it is I'm trying to do. Okay. In Python, when you define a function, you always have DEF, short for define, but it's only DEF. You can't have all of define. One or more spaces, the name of the function. The function cannot have spaces in it. It can have characters, it can have digits, numbers, it can have underscores, but it can't have spaces or other punctuation marks like ampersand or @ symbol or slashes or things like that. So basically letters, numbers, and underscores. And then open close paren. And inside of the parentheses are whatever arguments this function takes. This function doesn't take any, so it's just open and close. We'll look at an example where a function takes arguments in a second. And then a colon. And the colon's really important. So is the fact that there's a colon at the end of that, is that visible and clear to everybody? That there's the two dots on top of each other? That colon's really crucial. In Python, they use colon at the end of lines in a number of places that are really important, and it's easy for people to miss that, and then nothing works right. Okay. Now I hit return after I typed def show picked file open close colon, and notice the cursor, the blinking bar, is on the next line, but it's indented a little, and it's in a little box. Is that visible on this display? That there's a blinking vertical bar and a little box. We're good? That's where the steps of my program are going to go. And a function definition is basically just a sequence of actions. And they're the same kind of actions we've been typing down in the command area, but we can include them in a function definition. So we could say something like file equals pick a file. Okay? And notice that Jess is trying to help us out by doing some color coding. So def, it made bold and a dark blue, I think, and pick a file, it made bold and sort of a dark violet color. Those are saying that the def being in blue is saying that that's a keyword, that's a thing Python knows about, not something you get to choose. Whereas show picked file was something I chose, and it knew that, and so it doesn't highlight that in some fancy way. And pick a file is a function that already exists in Jest, so it got highlighted in a different color. And then I can say picture equals make picture. Notice again that it highlighted that. And then I can say show picture. And the box there is surrounding the entire body of the function definition. So it's telling us that that's what it thinks the body is that goes with that function definition. Okay? So it's trying to help us out by giving us information about its understanding of what we've typed. Now, a question is, how does Jest know, for example, when one function ends and another function begins? So if I type another function, how does it know where one begins and one ends? And if I click up in the body of show pick file, the box ends at show picture. It doesn't continue down to hello, okay? And if I click down in hello, the box goes around the print hello world, but it doesn't extend up into show pick file. How does it know that? It turns out in Python, these things are determined by indentation. This is actually quite unusual in programming. In most programming languages, these sort of what are called blocks are indicated by like open curly brace, close curly brace, or the word begin and the word end, something like that, that visibly marks the beginning and end of things. In Python, it's actually all punctuation. So these three lines are the body of show picked file because they are indented. 2 spaces is the default, but actually we could have done 3 or 7 or 12. And the body continues until we no longer have an indented line. So when we get down to here, because that line is not indented, Python sees that and says, oh, I'm done defining show picked file, and I'm doing something new now. And it knows that because that line is lined up on the left-hand side and not for any other reason, okay? So your spacing matters. How you indent your code matters to Python in a very profound way. This is, again, one of these things that's very different from what you're used to. In most of your writing, your indentation doesn't really matter. You can be totally sloppy about it. I indent some here, I don't indent there, I did whatever, right? And it all works out. In Python, the indentation really matters a ton, and if we get it wrong, it will not work. So we have to be very attentive to things like our indentation. Happily, Jest does a pretty good job of helping you out, both by automatically indenting when it thinks it knows what's going on, although it can be wrong about that, and by doing things like these boxes to indicate what is happening or what it thinks is happening. And so if, for example, let's say I go to this middle line and I move it over to the left, now it thinks show picked file has one line in the body, file equals pick a file, and this is no longer part of show picked file, and this is no longer part of show picked file. They're like not connected to show picked file anymore. Okay, and it's not going to work. But if I re-indent this, now everything's good again. Okay, so you got to be careful about your indentation, and you got to pay attention to what Jess is telling you, because Jess will try to help you out here. Okay. Questions about any of this before we actually save this and try using it? Okay, so to use a program, you press the load program button, and that will load the program up so that you can use it. You have to save it first, and if you forget, you get this, hey, you didn't save the file. And so I'll say, sure, I want to save the file. And I'm going to save it in downloads. You can put it wherever you want. So Wednesday, 2020 08 26.py. And it needs to end in needs to end in py, which is how you say this is a Python file. And you can call it whatever you want. I'm going to, in class, probably use these terrible names so that when I'll post these on Canvas, and this way I can keep track of which file came from which class day. So, I would assume you probably would not use names like this, but since we're going to have, files like this from every class day, it's useful if I have that kind of information in the name. So now I can load the program. Hey, it loaded. And I can say, let's first do hello. So now if I say hello, it says hello world. So it did what I said. It printed hello world. Lo and behold, I have hello world. Okay. Does that make sense? And now if I say show pick file, it's going to go through and do these through 3 steps. It'll call pick a file and assign that to file. It'll call make picture of that file and assign that to picture, and then it will show the picture, and it will do all of that in one thing. So instead of having to type all of those steps, all I had to do was say show pick file, and it did those steps. And now I can reuse that all I want. Show picked. And unfortunately, I don't have, I need to get more images on this computer. So we're just seeing the same snow picture over and over again to try to make you feel better about the heat. But if we'd had a bunch of different pictures, we could just be opening a bunch of different pictures here. And that would totally work. Okay? So we can use a function to capture a set of actions, a recipe, if you want to think about it that way, and give that a name so that we can reuse that over and over and over again. Okay? Questions? Okay. Now, we've got 5 minutes. Let's change this to say hello, Nick. Well, that's awesome if we want to say hello to me, but maybe we want to say hello to somebody else. Okay. Now, I could make a whole new function, but that would be kind of annoying. And if we think about it, let's say I wanted to be able to say hello to everybody in the room and everybody who's online, I would make a lot of functions, right? That would be a bunch of functions. I'd have a hello Yubo and a hello Zeke and a hello Yeshwant, right? I'd have a lot of functions before I was done. And so it would be nice if instead I could say hello and specify when I call the function who I want to say hello to. And that is where we can provide an argument to a function. We'll say name, person's name. Come on. So I could say hello, person's name. So I'm going to construct a string that has hello, comma, space. The person's name that we pass in as an argument, and then the exclamation mark at the end. So we're going to now call hello, and we're going to pass it a string, which is the name of the person we want to say hello to. And then we're going to construct this string by appending together 3 strings, hello, comma, the person's name, and the exclamation mark, and we will print that out. And that will allow us to say hello to lots of people, okay? So if I say load program, then I could say hello, Nick. I can also say hello. I can say hello. And hello. And so it's taking whatever string I provide, and it's constructing a new string using that and hello, comma, space, and the exclamation mark, and printing that out. And that gives me a lot of flexibility, okay? I don't have to write 20 functions. I can write 1 function, and I can call it in different ways, okay? And that's a very, very powerful thing, and we'll do that a lot over the course of the semester. So it's important that we understand what's going on when we provide parameters to a function definition like this, and when we call the function with arguments like this. And we'll definitely talk about this more on Friday, but we've got 2 minutes, so if there are questions now, that would be awesome. Yes, so I will save the video of the lecture, will get posted on Canvas, and the Python file at the top will be saved. I don't think there's a good way for me to save the actions down below. That'll be in the video, but there's not a good way for me to save that bottom window. But the top window with the function definitions will totally be shared on Canvas. So, questions? So there's a lot going on. Definitely ask if you've got questions. Got 1 minute, big opportunity. Okay, I'm going to call it quits. I will post stuff. The videos takes Zoom several hours to process them on their end. And then I've been editing the beginnings and the ends off because there's often like 10 minutes of me turning everything on and getting stuff set up, which is really, really not very fun to watch. So I've been trying to edit that off. That then adds another couple of hours of processing after I do that editing. It takes YouTube a while to finish that. So the whole thing takes a while. Don't expect the videos to be up there like instantaneously because there's a lot of processing going on. But I'll try to get all that up as soon as I can. And the Python file I'll do actually here in this room before I leave. So that should be up on Canvas like right away. So see everybody later. Any questions online? We good? See you folks later. Thanks for participating.